Hello everyone. I want to welcome you back again in my YouTube channel. Okay. Today I want to discuss about the tri-state logic. Okay. TSL logic gate will be discussed as a topic for our today's study. So without any delay, I want to go towards this tri-state logic and we will see about the working mechanism of this logic gate. So here the circuit is arranged in such a way that this is a point A, okay, which is the input, okay. Here plus 5 BCC will be connected, okay. 5 volt BCC will be connected, okay. Plus 5 volt BCC will be connected over here, and from here we'll take the output. So you can see here there are three transistor. Okay, I already told about the transistor working of transistor in my video in NOT gate. Okay, you can see from there how this transistor works and how this transistor will be in the cutoff state. Okay, but here in a shortcut I want to say that if this one is collector base, okay, collector, and this one is base, okay, and this one is emitter terminal. From when a current flows from the collector terminal, then it tries to go to the emitter terminal. Okay, then how this is possible? Okay, if a current is supplied through the base, then this transistor will be in active mode. Okay, then only the current will flow and this transistor will work. If the base do not get any current, then the transistor will not work. Okay, this is the simple logic. If you want to go in little bit detail, you can see the video which I have made just before this NOT gate. Okay, different types of NOT gate you can see there. Okay, this is the logic symbol. This one is diode. Okay, and here is the connection of one diode and another diode is connected here and is indirectly connected with the base of another transistor Q2. Okay, this TSL logic gate is simply a gate which works as an inverter. Okay, inverter means NOT gate. But here is there is a slightly different sense due to the use of this diode and the enable. Okay, sometime as our wish we can convert this circuit in a high Z circuit, high impedance circuit, have high resistance circuit. Okay, we'll see how. Okay, this is the validation of the truth table. Okay, if enable 0, whatever be the input, y will be in IZ. Okay, IZ means what, we'll see. Okay, after that when the enable is 1, if you give the a data 0, okay, input data 0, output will be low, input data low, output will be high, input data high, output will be low. This is same as the inverter working of NOT gate. So what is the difference between NOT gate and this gate? We'll see. Okay, for an example, let us see this first one. If the enable is made 0, then what happens? This diode is in what type of mode? Okay, this diode is in forward forward biased mode. Okay, that means this diode is this one is negative and the upper one is positive terminal. If negative is connected with 0, positive is connected with the 5 volt, then what happens? All the current flowing from 5 volt will be taken to the ground because enable is 0. Okay, 0 means we are supplying ground over here. Okay, then what happen? All the 5 volt will go from here to ground. All the data which is given from A, if you are providing a data high voltage, that means 5 volt, then also it goes to the ground. That means this will be in cutoff state. This transistor will not go because the base is not carrying any current. Then all the 5 volt current will not travel here because here is another transformer. Okay, this is already in cutoff. So this is cut off, then this also will be cut off because from here, okay, all the 5 volt will go to the ground because this is the easy way to go to ground because it is a complex way. Although it goes here, okay, then it makes this conducting mode. Then what even from here the current will be stopped because this should conduct, okay, because its output is connected over here for the conduction of this transformer Q3. Okay, so whatever be the condition, if you give the enable 0, then what happen? Then this circuit will be as a open circuit. Okay, there will be no any closed circuit because there is a high impedance. Okay, it works as an open circuit because this transformer will not work, this also will not work, and this also will not work. Okay. Now another one, if you give the enable one, then what happens? If you give enable one, I want to erase this drawing. If you give the enable one, then what happens? This one is base, this one is A, and the enable is 1. If you give enable 1, then this will be in reverse biased mode. Then this diode will not work, okay? In this case. So what happens? If the data is, if A is 0, A is 0 means this transformer will be in cutoff mode because base is not getting any current. Then what happens? From 5 volt, okay, the current flows from here to the collector, and we'll see its base will conduct or not. From 5 volt, the current will also come, okay, across this 2.2 kilo ohm resistor. Its color code is red, red, red. Okay, R, R, R. Okay, this 100 ohm color code will be brown, brown, yellow, or brown, black, yellow. I will say this later. Okay, RRR. Okay, this color code. From here, the current also flows here. Then what happens? This will be in conducting mode. If this will be in conducting mode, then what happens? The current flows from here. This 5 volt comes from here, from the collector. It goes to emitter and coming. Okay, it is in forward biased mode because positive voltage is coming from here. It will pass, okay, and from here it will stop because this is in cutoff mode. If this is in cutoff mode, then its output will not carry any current and this base will not get any current. So this will be in cutoff mode. So what even this 5 volt is coming from here to here, and from here we will take the output. Output means what? High output. Before, in high Z, what will be the output? Output will not be any kind of thing because all the current is flowing here. Okay, then we'll see the output. What will be the output? 0 volt, because this potential is in 0 volt and here no voltage is there. That means no voltage minus 0 volt. What is the difference between the potential? Potential difference means 0. Okay, so this is the thing. In high Z also you get 0. In if you give enable 1, then it is working as inverter. See, 0 is being converted to 1. So what even if you give the data 1? Okay, if you give the data 1, then this will conduct. This will also conduct. Yes, this will also conduct. Then what even from 5 volt the current is coming here. This will also conduct like before. From current is coming here. From here the base is also getting current. This collector is also getting current, and from here this is also working. Okay, because enable 1 means this is reverse biased. Okay, this will also work. And what happened? From 5 volt the current goes down. Okay, and here is resistor. It tries to follow the easy path, so it comes here. This will also be in conducting mode. So whatever the voltage was here, okay, before, this all voltage, okay, which is coming from here, it will be directly taken to the ground. That means if this is connected to ground, if this transistor is in conducting mode, then what even this is ground, all this circuit is ground from here to here. So if you see from here, then only you may get some voltage. Okay, then from here to here there will be no any volt because this is a connectivity. Okay, it is a closed circuit now. Then what even here is 0 volt, here is also 0 volt. What will be the potential difference? Potential difference will be 0 volt. So now here we have easily seen the working of this circuit. Okay, now there is a confusion for us. Okay, while we do our experiment in high Z also we will get 0 volt. In this case also you will get 0 volt. Now, which type of circuit can be considered as a high gate? Now, there is some problem in doing experiment. Okay, there is some misunderstanding for the students while performing this experiment. So, to easy our process, we have designed a circuit. We are connecting the circuit from here, or two resistance will be connected. Okay, I will show you here down. Okay, see here, these two resistance has been connected from here and the output is extended from here. Okay, I don't want to overwrite here. This output is being extended from here and again it is being connected over here and taken here. From here we are taking output. So in this case, what happened? We have seen when the enable is 0, we are getting high Z. Let us see here what happened when the enable is 0. When the enable is 0, this will not work. Okay, this will not work and this will not work. All the 5 volt will go, okay, some part of 5 volt will go to the ground, and this will go to the ground because this diode is in forward biased mode. Zero means negative is gonna give negative, okay, from positive where it is getting positive. So whatever, it will be high Z. So let us see the output. From 5 volt, some part of voltage goes in this circuit. Here is no any transistor, okay? It do not depend upon the base current like the transistor. So what even from 5 volt, the voltage will go from here to the 10 kilo ohm resistance, and from here to the 10 kilo ohm resistance, it goes to ground. So this, when two resistors are connected in series, then this works as a voltage divider circuit. Okay, from here we are giving input volt 5 volt. What will be the output? 10 kilo ohm resistance is here. This one is R1. This one is R2. Okay. Then input voltage is 5 volt. Then what will be the output voltage? We have the formula for output voltage will be equal to input voltage multiply. Okay. Input voltage multiply R2 by R1 plus R2. R2 is 10, R1 plus R2 is 20. Okay. Okay. This R2, this R1. Then what happened? This one is 10 divided by 20 means half of input voltage. Then what happened? 5 voltage supplied from here. We are getting output from here actually. This circuit do not work. We are not getting output from here. So at this case, at the case of high impedance, okay, we are getting the value of Y 2.5 volt. You can see here. Okay, if enable 0, if A is given 0 or 5 volt, the circuit do not work. But this 2.5 volt we are getting from here, from this 5 volt, the current flows from this circuit to, and here there will be the potential drop. And what even from 5 volt, if 2.5 volt will be dropped, then we are getting 2.5 volt, or by this formula also we are getting. So there is the difference between high Z. The complication has been solved because this zero, if both 0 0, then we will be in trouble. Okay, so the Viva may ask you why we are connecting this. Okay, why there is 0 over here. Okay, what even if we do not connect? Okay, many questions may be there. So if you understand the working of this experiment, then it will be easy for you. So from the next step, okay, if you give 5 volt, that means high. If you make the enable high, then there will be no any high impedance. If you make the enable high like this before one, okay, the enable high, then it works as an inverter 0 1 1 0. The enable high, then what happen? 0 5 5 0, like same before. Okay, if you make the enable high, then what even this will not work. Okay, wherever it is connected, it will be equal to its disconnection. Okay, this one will if you give the enable 0, then what even it will, oh sorry, it will give the enable 1. Okay, I'm not talking about 0. It will give the, if you give the enable 1, then there is no use of using this diode because it will be like an open circuit. Okay, open circuit, current cannot flow through this diode. So what even it will work as a not get like before. From here base is getting current, from here also base is getting current, from here also the collector is getting current. This will be in conducting mode, all the voltage will drop, go from here. Okay, if you give the A high, then what happen? We are going to get Y low. And that means what happen? From here all the current flows from here, and this will conduct, means this will also conduct because its emitter will get current, and this will also conduct. All the voltage will be taken to the ground. So what even now? Now you can say that Y will get 2.5 volt like this. No, because from here on here, Y will, this point will be 2.5 volt. But as soon as this will be connected with the ground, okay, as soon as this Q3 perform its work in the working state, then what even it takes all this voltage to the ground, because this voltage is also trying to go to ground. It will not go through this 10 kilo ohm resistor. Okay, so what even Y will be low. Okay, Y will be low. Don't be confused. Now, what even if A1, then Y will be low. It is working as a, see, if A1, this one, if A is 5, Y will be low. Now, what even if A is 0, Y will be 5. Let us see. If A is 0, this will not work. Okay, this will not work. That means this base is not getting any kind of current, so it will be in cutoff mode. So from here the current flows through collector, from here the current flows through base, and this transistor will be in working state. So what happened? From here the current is flowing up to here, Okay, then what even from here, this will not work means this will also not work because its emitter is connected with the base. Okay, then what even current is coming up to here, 5 volt is coming, there is no any potential drop because no two resistor are connected in series, you can see here. So what even from here, it will get directly 5 volt. Here there will be 2.5 volt. It is not so that these two are connected in series. Okay, these are not the voltage source, so don't be confused. Okay, here is 5 volt, here is 2.5 volt. So the maximum voltage will be out from here. I want to make you clear. At what case it will be 7.5 volt? If you connect a 2 voltage battery, okay, this one is 5 volt battery, okay, and this one is 2.5 volt battery. Then if you measure from here to here, it will be 7 volt. But this is just the flow of current, okay? From here 2.5 volt is flowing, from here 5 volt is flowing. So only up to here, not down, okay? Because this is not connected. So from here, if you measure, these have Y have connection on both circuit. So it will show the data of 5 volt. Okay. So at this case, there will be no any potential drop also because this 5 volt is also connected here. So here also 5 volt coming, here also 5 volt coming, okay? And 5 volt will go ground. Although it tries to decrease the voltage, the coming voltage, but this will equalize. So this Y will be higher. I hope you know about this working of TSL gate. So it is different from inverter because as our wish, if you give the enable 0, the circuit will be high impedance circuit. Okay, so high impedance circuit, there is little bit confusion how to detect this 0 volt. Okay, in both cases 0 volt is coming. Okay, then there is trouble, which one is high impedance. Okay, you cannot say enable 0 then high impedance, enable 1 then high impedance 0, be confusion. So what even if you enable is actually enable 0 gives high impedance, but here if you use this two resistor, then our work will be furthermore clear. So I hope you have understood this. Okay, I have tried my best to share my knowledge. Okay, it took me last night to study this logic gate. Okay, how uh, this will work. Okay, so today I am preparing this video because we are having our practical exam right now, so it will be helpful to my friend. Okay, and it will be helpful to the junior students in coming days. Okay, I hope so. Okay, by saying this much, I want to sign off from my today's video. Okay, we'll meet again with the new concept of science. Okay, if you like the new concepts in scientific world, then please subscribe my channel. Okay, and share this video to the interested students. Okay, who want to learn. Okay, who want to get something new to learn every day. Okay, then you can subscribe, you can share, you can like my channel. Okay, this video. Okay, okay. Have a nice day. Thank you very much. Bye bye.